Okay, good day, students. Today we are going to solve two more examples on the Newton's laws of motion that I explained the previous class. The first law states that a body will continue to remain at rest or on uniform velocity along a straight line except acted upon by an external force, right? And then the second Newton law of motion states that the force impressed on a body is directly proportional to the rate of change of momentum, and it was that law that we used to find the formula of force, right? And then the third law states that for every action there is an equal and opposite reaction. Okay, and we solved two examples. So let me solve another example today. The question says that if a constant force P of magnitude 108 Newton is applied to a body of mass 10 kg, find the acceleration produced in the body, assuming the body starts from rest. What velocity does it attain after 6 seconds? Okay, so let's try to solve that. A constant force P of magnitude 108, P equals to 108 Newton, solution 108 Newton, okay, acts on a body of mass, all right, 10 kilogram. Find the acceleration produced in the body, assuming the body starts from rest. So we say that the force equals to mass times acceleration. Okay, that will be 108. Okay, 108 equals to, what is the mass? 10 times acceleration. Okay, so we have acceleration equals to 108 over 10. So the acceleration is 10.8 meter per second squared. Okay, all right, so that's the acceleration. And then the next question states that assuming the body starts from rest, what velocity does it attain after 6 seconds? So pay attention. In this question now, we will have to apply the equations of motion. And let me remind you of the equations of motion. Okay, the equations of motion. Okay, we have number one, V equals to U plus AT. Number two, we have S equals to U plus V over 2 times T. And then we have number three, we have V squared equals to U squared plus 2AS, right? And then number four, we have S equals to UT plus half AT squared. Just as a reminder, okay? V equals to final velocity, okay? Are you seeing that? U equals to initial velocity. All right. A equals to acceleration. T equals to time. S equals to displacement or distance, as the case may be. Okay, so the question now says that assuming the body starts from rest. So we have solved the A part of the question. Now we want to look at the B part. Assuming the body starts from rest means that initial velocity is 0. Okay, what velocity does it attain? So we are looking for the final velocity. Did you see how I got that? The initial velocity is 0, the final velocity is unknown. And then we know from the first question that the first solution that A equals to 10.8 meter per second squared. Okay, and then what velocity does it attain after what? 6 seconds. So time is what? 6 seconds. So we have V. So we are looking for V. We know U, we know A, we know T. So what formula suits our question? It is the first formula. V equals to U plus AT. So we say V equals to U plus AT. Okay, V equals to U plus AT. So our V will be what V equals to U is what? 0. Our A is 10.8 times our T is what? 6. So we have, now pay attention to that. We have 0 plus 10.8 times 6 is what? What does it give us? Check it out. We have 0 plus 64.8 meter per second. Okay, that will be 64.8 meters per second. So that gives us the final velocity. Is that clear? All right, so let's take another example before we round off today's class. Okay, let's take another example. Example 4. A body of mass 80 kg is placed in a lift. Calculate the reaction between the floor of the lift and the load when the lift moves upwards. A, first at constant velocity, second at an acceleration of 2 meters per second. Now pay attention. So we have a lift solution. Pay attention. We have a lift. Let's take this as our lift. Okay? Remember that the lift, the weight is in the lift. Okay? The weight has the load has a weight, of 80 kg, and the weight will always act downwards. Okay? The weight will always act downwards. And remember that the formula for weight is what? I said it last class. Mass times acceleration due to gravity, mg. So the weight here will be, 80 times g is 9.8 from the question. Okay, 80 times 9.8, that gives us 784 Newton. So the weight of the body is 784 Newton. Okay, and from the third law of motion, third Newton law of motion, it says for every action there is an equal and opposite reaction. Okay, so if there is a weight acting down, there would also be a reaction. A reaction R. Okay, the reaction R will be opposite. We act in the opposite reaction. Okay, so we have two forces: the reaction and the weight of the body. Okay, so the first question says find the reaction between the floor and the lift if the body moves upwards at constant velocity. All right, so at constant velocity, please pay attention. At constant velocity, acceleration is 0. Whenever you hear constant velocity, what it means is that the acceleration is 0. Okay, so that means A is 0. Now remember that force equals to ma, right? Force equals to ma. The force acting on the body is equals to ma. But in this case, we have two forces acting on the body. We have the weight and we have the reaction. And so what we are going to now say is not going to be force. What we are going to say is net force. Net force is ma. So how do we get the net force? Net force is going to be reaction minus weight. Why? Look at that. Reaction minus weight. If you remember the study of vectors, for those of you that you did physics, in vectors, when two vectors are acting in opposite direction, the resultant or net is obtained by subtracting, the two vectors. So the reaction is going upward, the weight is going downward, so we subtract. So we have reaction minus 784 equals to ma. All right, but pay attention to this. Remember that A is 0. All right, so we have reaction minus 784 equals what's our m? 80. That's the mass. A is 0. So we have R minus 784 equals to 0. R equals to 784 Newton. So for the first question, the reaction is the same thing as the weight. Why? Because it is moving at constant velocity. Is that clear? Is that clear? All right, so let's take the second question. Question B. That what is the reaction when the lift is moving upwards with an acceleration of 2 meters per second squared? So we have the lift, the load is inside the lift, and the weight is 784 Newton. And of course, in this question, we are not putting into consideration the weight of the lift itself. Okay? And so there should be a reaction here. Okay, the reaction. All right. And then we are told that the acceleration is 2 meters per second squared. So same thing we did in the previous question. We say net force equals to ma. Okay, what's the net force? reaction minus 784, R minus 784. Now, someone will ask me a question. Why did we say R minus 784? Why didn't we say 784 minus R? The reason is because the question had already said that the lift is moving upwards. All right, the lift is moving upwards. So that means that the reaction at that point would be greater than the weight, since it is moving upwards. Assuming the lift is moving downwards, the weight will take higher value than the reaction. Are you get what I'm saying? Will take higher value than the reaction. So in that sense, because it is moving upward, that is why R came first. So it's R minus 784 equals to MA. And what is our A in the question? Our A is 2 meters per second squared, right? Okay, so we have R minus 784 equals to M, which is 80 times 2. So we have R minus 784 equals to 160. Okay, so we have R equals to 160 plus 784. And what does that give us? It gives us 944 Newton. So you discover that the reaction is dependent on the acceleration. When the body was at rest, the reaction was exactly equal to the weight. But when the body was in motion, the reaction wasn't necessarily equal to the weight. All right, is that clear? So you will observe that when you are in a lift, and you are moving upward, you feel heavier. When you're in a lift and you are coming down, you feel lighter. Okay, maybe I will talk about that. I should talk about that next class. Okay, thank you. Have a beautiful day.